Hello, and welcome back to I Know How To. Excuse me. Today we're going to talk about how to analyze an algorithm using Big O. Big O describes how quickly runtime will grow relative to the input as the input gets arbitrarily large. There's different kinds of Big O notations. The ones you want to steer away from are the ones in yellow. These are the ones that when data grows very large, it requires a lot of memory to perform the operations. I'm going to share some examples of linear, log linear, and quadratic. Simply remember an algorithm is just a procedure or a formula for solving a problem. I'm also going to work out of Jupyter Notebook using the time it function. These are the examples that I'm going to cover in Jupyter Notebook. The quadratic time problem is the first problem we're going to cover. The second one will be a linear time example, what that looks like. And then the last one will be a logarithmic time example. So in Jupyter Notebook, we're going to go ahead. I've already ran this. So here you want to first evaluate the problem just by looking at it. The first line is going to execute n times. The second line is going to execute n times because that's what's in the range. So n times n is n squared. That's the definition of quadratic. The second example is going to be, it's just going to run 5 times n times. And when you're dealing with Big O, you always drop the terms. So you're just going to end up with n, and that is the base definition of linear. This third one is an example of logarithmic. So when it starts out, x is equal to 5 times whatever n is. Now, while x is greater than 0, this is really not relative, so I'm going to remove that. What's the crucial part of this is n, and this is a division round down, so a floor division where it rounds the down to the nearest whole number, but it's actually dividing it by 2 with every loop of it. So that when you're taking your original code and you're dividing it by, you're taking it in half, that is the definition of logarithmic. And that notation looks like this. So that is logarithmic. That's what that is. So we can run to see what the times look like. So right off the bat, linear. So the first one is the quadratic time in nanoseconds. The second one is the linear time. And then the last one is the logarithmic time, which is interesting because I would have thought that linear would have been a faster time. So that's the comparison right there. I also have a matplotlib right here. I want to add logarithmic comparison. Logarithmic. Excuse me. And so I would just say n log n. This is matplotlib, and I want to see visually what that looks like. Log, it doesn't like log. Let me see. Let me look that up right quick to find what I'm doing wrong there. Give me 1 second. Okay, so to correct this, I'm going to use the numpy function. And I'm going to try running that again. All right, so here we're going to see which one grows exponentially larger and faster, and it clearly is that quadratic. So quadratic is definitely one you should definitely stay away from. Now, even though the performance here, it appears that this is would perform better, but that's because I only have 5 here. But if it was a larger number, then you would be able to really see the difference. I'm gonna run that and see what happens if we can see the difference there. So I'm gonna pause for a moment. Okay, so as you can see here, when the numbers are really large, the logarithmic outperformed all the other algorithms. So that is all that I have for this one. I genuinely love creating these how-to guides. This channel is my hobby and a fantastic way for me to sharpen my skills. And I can't wait till I can transform into a full-time role. So remember to subscribe for more tutorials. Connect with me on LinkedIn. I love to hear from you.